Good afternoon. Welcome to Henry Mast Greenhouses. My name is Scott Stiles. Graduated from Michigan State University with a Bachelor's of Horticulture degree. I've been a grower for 14 years in the industry. I'm in my role here at Henry Mast Greenhouses General Manager for a little over a year. So there's a lot that happens in a greenhouse. It's not just planting flowers and getting them timed out, but it's facilities maintenance, it's scheduling, it's managing people, and along with having a knowledge of plants and how they operate. And really my role here is the oversight of Henry Mast Greenhouses, and I get involved with the growing, get involved with the operation, and our operations manager as well. Introduce you to our Director of Growing, John Davies, and our Director of Operations, Chuck Jager, here.
I'm Chuck Jager, Director of Production at Henry Mast Greenhouses in Byron Center, Michigan. Been here a little over 20 years. I look at that production cycle from taking it from the sales plan through implementation, making sure that we get the right products ordered, coming in at the right time, and that's all coming together into a cohesive plan for the growers to have a formula for success. And then I pick that up at the tail end of the growing process again, overseeing the shipping, availability, and quality control on the end of the crop.
Hello, my name is John Davies. I'm Director of Growing here at Henry Mast Greenhouses. I've been with the company since 1991. Interesting for you all, maybe I started as an intern here from Michigan State. Throughout the years, been able to develop into a section grower and took on more duties, ended up being a manager here, and now as Director of Growing, my duties would consist of preparing the cultural plans for the crops, timing, pesticide schedules, really guiding and educating our next level of growers. So all the section growers here, we have close to a dozen of them. They would be my responsibility.
Just to kind of give you a brief description and the history of Henry Mast Greenhouses. We are started in the 1950s. Our founder, Henry Mast Sr., started production in bulbs and poinsettias and Easter lilies. But now, instead of having 4 or 5 programs, we have about 160 programs, so a lot of complexity happens here in the greenhouse. And we're composed of 30 acres of greenhouse, 4 sites here in West Michigan. We really work with 2 main customers, that is Meijer retailer and the Home Depot. Focusing on the Meijer chain, we supply about half of the Meijer chain in garden products, and we supply all of the Meijer chain in floral. At the Home Depot, we are a garden supplier, and we supply about half of Chicago, all of the St. Louis market, and the Wisconsin market.
They're recirculating ebb and flood systems. So you've got storage tanks that hold the water. When you're ready to, you can fill those up with a nutrient solution. You got your macros, your micros, your soil adjuvants all mixed and pre-blended together in there. So you can open up the tanks, you can keep the different tanks, you can keep different recipes. So when you're ready to water one crop, you can open that up, releases it into the pumping pit, as we like to call it, pumps it up through the flood floors. There's air actuated valves that are timed, so once that floor is full, it switches, starts to flood the next floor while it starts to drain back the first floor. That water drains back to the pumping tank and it can get recirculated. And then when you're done with the water for the day, when you're ready to put it away, we've got a cloth filter system that filters all the water down to 10 microns before it's put away. That helps eliminate a lot of the soil or other debris that might have washed back to the tank, which a lot of that debris can then carry along with it water mold, zoospores, and such like that we obviously want to get out of our system before we reuse that water again. Some of our houses also have curtain systems installed. All of our glass houses around here have got energy curtains because you don't have that extra buffer. That takes a lot of heat at night to try to heat a glass greenhouse without a curtain. So it's been standard practice whenever we've built a glass house that we've installed a heat retention curtain in addition to that glass to maintain our temperature overnight. We still need to heat the greenhouse during the day, which is our highest heat demand in those ranges, because you've got the glass that's emitting heat to the atmosphere all day long without the advantage of the curtain in place, which you retract the curtain in the daytime and the wintertime to allow the light into our greenhouse. So we have glass greenhouses. We have older wide-span glass greenhouses. We have newer, I'll call it moderate width span greenhouses that are curved glass. Both those styles of glass greenhouse have got wind and lee venting, meaning you've got vents on both sides of the greenhouse. Our environmental control keeps track of what direction the wind's coming from, so it modulates, and the speed of the wind, so it can modulate the vent angle based on that speed of the wind, based on the outdoor temperature. The indoor temperature takes all of that into account to determine a vent opening. And then our newest design of greenhouse that we've been building for the last about 9 years, 10 years or so, they've got a ridge vent. So you've got the two sides of the greenhouse and it lifts up, letting the hottest air out of that peak of the greenhouse.
All right, here we have an injector. We need to inject fertilizers into our irrigation water. So each injector we have set up around the farm. Each covers 3 to 4 acres. So we will inject NPK, nitrogen, potassium, phosphorus, nitrogen, phosphorus, potassium. Through one injector, we also inject a minor nutrient package into our irrigation water. We also have the capability of injecting then either PGRs or other elements separately into our irrigation systems. Here at Henry Mast, because of the different structures we have, about 50% of the production has concrete flood floors. We also have bench systems. The bench systems would either have chapin or drip type irrigation. We also have capillary mats on some of those benches for irrigation from the bottom. We have booms in several of the acreage, mostly used for propagation, but also irrigation. So many different types of irrigation systems, which allows us to, with different crops, utilize best practices for irrigation. So here we have a grower spraying out in the greenhouse. We use various sprays, pesticides, calcium nutrient sprays, PGR, plant growth regulator sprays. So there's different ways of applying these things. Sometimes it's through fog systems. Here's a hydraulic sprayer, high pressure spray over the top. It's very regulated how we can apply pesticides. So safety standards are up. You can see we wear personal protected equipment. Zones are closed off to the workers when we spray, and we follow these guidelines throughout the production schedule.
Benches, the benefit to the bench is the grower. The grower has better control over the moisture and the drainage of the crop. I like benches. You can get around as a grower. You get between the benches, you're up close and personal with the crop. Where when you have a floor and some of your plants are 10 to 15 feet away from you being able to see them, knowing what's happening with your crop is never quite right there at arm's length, where the bench always keeps your crop at arm's length. And so from a grower standpoint, benches are great. You're up close and personal with your crop. You're able to care for it the best you can. we've expanded our container growing, but I think a big reason our container growing has expanded is because our quality is reflecting to our consumer. Our consumer sees the good quality, they like our product, and so we continue to expand in that category of growing. Really diversified what we're providing for our customer, where we used to be the customer that would provide one item to a lot of stores. We now provide a lot of items to a far fewer number of stores.
And, the logistics of our company is a paramount and instrumental avenue of how we get our crop to market. You can see that we take very cautious preparations to get our product to our consumers' hands at 100% the same way it leaves the greenhouse. And because right now we're on pay by scan, and what that means is we only get paid for what sells through the register. So it's very, very vital to the health of our organization to sell as much as we can at market, and not cutting corners to get there. And we feel like we've spent a lot of time and man hours to be able to accomplish getting our product to that within a 24-hour window to market, and that really has helped our sell-through. As you see, when we wrap our carts, that's the finished product that's going to our stores. And there's a lot that happens behind the scenes of that, and once it's on the truck, what happens, and there's a lot that goes into it to get to the shelf. On an average day in the spring, we're loading anywhere from 30 to 40 semi-loads a day, and the amount of hands that takes, and the amount of planning that takes, and the leadership that's involved up and down the management chain. So it's real important that we're good time managers and good system users. And as you see, the conveyor systems that throughout this video clip of the tour of the greenhouse, we need those conveyors just to be able to execute that peak demand.
Booms for irrigating, traveling irrigators again, irrigation nozzles. Some of those actually have little tubes that'll irrigate into the pots as it passes over the pot. Not getting the whole foliage wet, just hits the pot itself, so it squirts a small amount, and it's getting a small amount of the foliage wet, but gets the soil properly irrigated.
There's still times when we need to hand water, when we're touching up edges or young plants where we just want to give light shots and the system that's in that greenhouse doesn't allow itself. If it's a flood floor, sometimes you just don't want to be that wet. But we try to minimize hand watering, try to minimize watering over top where we can, simply for additional disease control, and the labor aspect where we have systems that can automatically water, and we can minimize the amount of hand watering, and typically our systems are more uniform. In one of our areas where we have additional cooling requirements, we added a pad on the end, which we incorporate water through the pad, pulling air through that water that actually cools then the greenhouse. In all of our poly structures, it's a double poly roof, and we put air in between the layers for insulation value, and it also keeps the plastic turgid to the roof. Most of these systems have a central fan that inflates the whole range. There's a manometer that helps control the pressure of those roofs. If you look at them, they look like big pillows over top, but that's how we can control the pressure in the inflated roofs.
You're able to care for it the best you can, but getting the product onto and off of the bench is far less efficient than what we have on the floors. With our floors, a lot of our houses with floors are equipped with conveyor belts. So number one, you can conveyor it out, and a lot, our flood floor areas, which is a large expanse. So we've got 8, 11, probably 13 acres of flood floors here. You can roll the carts on any of these flood floors. They're all concrete covered flood floors. Once you start packing a large volume out of here, you can either roll the carts in or use the conveyor belts to get the product out. So there's obvious efficiencies attached to the floor areas to get around, but from a grower standpoint, I've always liked benches.
Here at Henry Mast, again, throughout the greenhouses with many different structures, we have different basket systems. A typical system would be called an ecosystem, where you have 2 drums with a cable that the plants hang off of, and they simply go around. With a 1 central watering station, it's either mechanical or electrical eye that sees the basket, and we can irrigate so many ounces of water that we wish per basket. Those are fairly maintenance free. They're good systems. One of the disadvantages is getting to them. So we have to use tall safety ladders to get product up and down, which is labor intensive and sometimes difficult. More recently, our basket systems is we have an area within each system that's hinged, and it can come down right to the worker level, and as the baskets travel, which makes it obviously simpler and safer.
Because of the adaptability of conveyor belts, we've been very happy with that. We've implemented that wide scale across the place. Any new greenhouses we put up in the last 20 years pretty much have got conveyor belts installed in them. From planting perspective to spacing to bringing the product out and shipping it. Keeping our labor costs down is one thing. We're never going to implement so much technology here that this whole place is going to be run by computers and robots, and there'll be no need for experienced professionals as well as general labor. I mean, there's too much happening around here and too diverse of a crop makeup for us to be able to implement technology to that level. Double poly with a non-concreted floor. It comes down to return on investment. You know, when you're a growing company, not just growing crops, but an actual company that's growing in size, which we are, you know, you're trying to maximize your bang for your buck. You want a quality greenhouse that'll produce a quality product, but certain crops have more needs than other crops. We have, let's say, we're trying to keep a balance of our high-tech houses to our what we consider to be a lower tech house, but it is still a quality house. It's computer controlled with good irrigation and ventilation and heating systems. Enough of a balance of those, we'll call them higher tech houses, to I'll say the moderate tech houses, where they're more of a spring, summer, early fall growing house. So we're expanding in that realm of technologically advanced greenhouses currently. At some point in time, we'll probably have to maintain our balance of our higher tech houses, but at this point we're looking to expand on our growing and finishing end of things.
We're planting up Easter lilies. It's a crop we've been doing for 40 years. Henry Mast, we've been producing 150,000 lilies, plus or minus, every Easter. It's an interesting crop. A lot of the research that's been done was done at Michigan State years and years ago, as far as the timing of Easter lily and how to manage that. Easter, obviously, you know, lands on a different date every year, although the bulbs get dug in Northern California pretty much when they're ready. So the front end of the crop doesn't change much, but we need to be able to time that crop for Easter, which is a moving target year to year. The bulbs come in, we dip them in a fungicide and a miticide, then we plant them up. They need 6 weeks or 1,000 hours of cooling at 42 to 44 degrees. So we rack them up on the carts, and the carts go in the cooler, and then mid-December we can take them out. and once 1,000 hours of cooling is done, put them out on the bench, and then we start forcing them. Bulb crops, we have a cooling time and a forcing time. That's the terminology.
So, 30 acres of greenhouse, you got to figure out how do you get all this done and marketed towards a very narrow period, really 8 weeks when we can bring our crop to market. And those are the last 2 weeks of April through May through the first 2 weeks of June. So each planting line, we have a planting line at each site. So here in Byron Center, there's 3 of the sites. Each is responsible for the execution of getting the crop in and the crop harvested. We use automation with tower busters and drops onto a soil line, and a lot of our folks work on this production line. And as you can see in the clip, it moves at a relatively quick rate, and that is a lot of the success of it. These sites are managed by site managers, and they have a metrics that we go by to try to hit our target window. So as you can kind of see, it takes both automation, and it takes also a lot of what we qualify as our biggest asset is the people of our organization.
We're not building, glass houses with boiler heat and flood floors lately. We've got a fair amount of those. We've got enough of those to produce our most sensitive holiday crops, enough of those for our propagation space. So we're able to keep those more sensitive crops in houses with better heat via the boiler system. Runs a little drier with the hot water heat on a boiler system. They've got bottom heat so that you get good root growth, particularly in the propagation environment. You got good light for crops like lilies or propagation for that matter. So we've also got various heating systems within our greenhouses. Some of them have unit heaters. That's the simplest of the heating systems we have around here. And some of them have got hot water boiler systems, which are a more expensive, more complex system to operate, but overall it's more efficient as far as BTUs of heat, BTUs of gas burned to the BTUs of heat actually applied to our crop. We're more efficient with our hot water systems and with our unit heaters, and we create generally a drier, overall for West Michigan, we can create a better environment. So all of those ranges with hot water heat also have not only hot water pipes overhead radiating heat onto the crop, but they also have hot water circulating under the crop, whether it be through pipes buried in the concrete floor or pipes circulating under the benches in the houses with benches on them. Another aspect that we've engaged on with technology has been spacing robots. We've had 2 spacing robots for the last about 4 or 5 years now. But they're pretty good at spacing anything from 6 inches up to about 10 inches. They're really good at that. They can get up to, I believe, a 13-inch plant. Picking it up is not a problem. Smaller pots, they can grab the small pots no problem, but when you get into spacing small pots, there's so many units that there's a lot of pieces to move that they get bogged down in the time they spend spacing a bay, that sometimes it's almost easier, not necessarily easier, it's quicker just to get the job done to send a crew out that can handle more pots over a shorter period of time when you've got a very narrow window of the right time to space your crop. Our propagation blocks are computer controlled with fog and traveling irrigator boom misting that lays a light mist over the crop on a periodic basis. But we've found a third use for our booms in night interruption lighting. So the last 3 years or so, we've had LED lights on our booms in some of our prop blocks. We started out actually in this block with a set of LEDs, and then we've added it to blocks across the street and further blocks further down. So those LEDs have allowed us to do night interruption lighting with our booms.
Here at Henry Mast Greenhouses, we continue to expand our production facilities. In the fall of 2020, we started a build at our west facility, totals just over 100,000 square feet of growing space. We completed this expansion just before the spring of 21. As we've gotten through 21, we also have another expansion plant here at Henry Mast Greenhouses, again at our west facility. We've started a second expansion at our west facility, building a Quonset farm. The Quonset farm totals just over 150,000 square feet of 14 individual hoop houses connected into a central head house. The head house allows for carts to be staged and product to be staged from both setting plants down in the Quonsets and loading plants out of the Quonsets. The ability to have separate microenvironments allows us to grow crops at different temperatures to be able to hold and or push crops towards market depending on what the market is telling us to do. We should complete our second west expansion of Quonset farm come early spring of 2022.